Okay, alright. I think we're good. Yes. Okay, hello there everybody, this is morrow13 here, and welcome to an experimental stream. What I like to call stream chat, but I really gotta work on the name. Today's stream is an experimental one called Stream Chat Teaches Morrow. In case some of you may not know, well, it's definitely an experimental idea. It is rare that the stream chat would tell me a subject on the topic that the stream is on. Like, for instance, today it's a math stream. So if y'all want to tell me about what kind of subject of math that you want me to take a look at, please let me know in the chat. And also, once again, this is indeed experimental, so there's going to be a few rough patches here and there, but I'm hoping that you all will be able to help me out when it comes to that. Alright, so let's go ahead and have ourselves some fun. And oh yes, I was watching a Weed Shop 3 live stream just because it's that trying to get some ideas on how I want to run my weed shop in the game. Okay. And so, okay, let me go and put this thing, no. Yeah, there we go, we put you here, there we go. Alright, we're good. Okay, so it looks like there is no request, for a math subject. So let's see here. Oh yeah, I gotta get my notepad up. There you go, my notepad up. And let's see. Okay, so we will be doing algebra. I know we did in fact do an algebra stream before, but knowing I do believe there is a such thing that there's a basic algebra, then there is advanced form of algebra. So we're gonna see if math is definitely the space language that I think it might be. Like, as you all can see here, look at that algebra. That is look like freaking space language to me. Alright, so let's get okay, so let's see. I guess we'll go to this one maybe. Yeah, it has 4.6 million views, and maybe he gets the idea. Alright, let's take a look.
Whatever the day brings, Grammarly helps you communicate smarter.
Hi, this is Rob. Welcome to Math Antics. In this lesson, we're going to learn some really important things about a whole branch of math called algebra. The first thing you need to know is that algebra is a lot like arithmetic. It follows all the rules of arithmetic, and it uses the same four main operations that arithmetic is built on. Addition,
Okay.
Subtraction, multiplication, and division. But algebra introduces a new element, the element of the unknown. When you were learning arithmetic, the only thing that was ever unknown was the answer to the problem. For example, you might have the problem 1 plus 2 equals what? The answer isn't known until you go ahead and do the arithmetic. Now, the important thing about algebra is that when we don't know what a number is yet, we use a symbol in its place. That symbol is usually just any letter of the alphabet. A really popular letter to choose is the letter X. So in arithmetic, we we would just leave the problem like this. 1 plus 2 equals blank. And we would write in the answer when we did the addition. But in algebra, we'd write it like this. 1 plus 2 equals x. The x is a placeholder that stands for the number that we don't know yet. What we have here is a very basic algebraic equation. An equation is just a mathematical statement that two things are equal. An equation says the things on this side of the equal sign have the same value as the things on the other side of the equal sign. In this case, our equation's telling us that the known values on this side, 1 plus 2, are equal to what's on the other side, which happens to be the unknown value that we're calling x. One of the main goals in algebra is to figure out what the unknown values in equations are. And when you do that, it's called solving the equations. In this equation, it's pretty easy to see that the unknown value is just 3. All you have to do is actually add the 1 and 2 together on this side of the equation, and it turns into 3 equals x, which is the same as x equals 3. So now we know what x is. It's just 3. That almost seems too easy, doesn't it? And that's why in algebra, you're usually given an equation in a more complicated form, like this. X minus 2 equals 1. This is exactly the same equation as 1.
Okay. Alright. Okay, I definitely, when I was in school, I have seen people do this. And I was thinking to myself, how in the world can people do that? Like, B minus 3 equals something. Or there's 4 minus C equals, okay, yeah. Okay, so it's B, okay, you see what I mean? How in the world can people do that? My head was flabbergasted in school when it came to that. Okay, so... let's see. Okay, so x plus 2 equals 4. So... oh, okay. Okay, this one makes sense, but it's gonna get a bunch more complicated real fast, I bet. Yeah, it is. Possibly.
Plus 2 equals x, but it's been rearranged so that it's not quite as easy to tell what x is. So in algebra, solving equations is a lot like a game where you're given mixed up, complicated equations, and it's your job to simplify them and rearrange them until they're nice simple equations, like x equals 3, where it's easy to tell what the unknown values are. We're going to learn a lot more about how to actually do that, how to solve equations, in the next several videos. But for now, let's learn some important...
Okay, so let me get this straight. Algebra is basically mixed up math. So you need to unmix the math. Okay, so, once again, I'm sorry, I'm losing track of thought. So in algebra, so this guy is saying that algebra is mixed up math, so you have to unmix the math for the math to make sense. Oh man, that's like freaking, that's similar to perhaps the Gordian knot. Except for the Gordian knot is algebra. Alexander the Great was saying F the Gordian knot and decided to cut the Gordian knot in half. Okay, enough of that Windows recommended editor. No, thank you. Oh, that's a great description. Mixed up math. Yeah, thank you. Okay, Sultan Mr. Spacey Gaming. Sultan Mr. Spacey Gaming says, okay, what is 1 plus 1? Okay, 1 plus 1, that is 2.
rules about how symbols can and can't be used in algebraic equations.
Okay, more. What is the area of a rectangle 2 by 6? Like a 2 by 6 rectangle. I can only assume is that 2 is the height. No, 6 is the height and 2 is the width, I think. That would be 4, I think.
The first rule you need to know is that the same symbol or letter can be used in different algebra problems to stand for different unknown.
Okay, how long is this rope? Hands, morrow, a knot. I really don't know how long the rope is. So I guess I have to take a guess. Maybe 5 inches?
Values. For example, in the problem we just solved, the letter x was used to stand for the number 3, right? But x could stand for a different number in a different problem. Like if someone asked us to solve the equation 5 plus x equals 10. In order for the two sides of this equation to be equal, x must have the value 5 in this problem, because 5 plus 5 equals 10. So x, or any other symbol, can stand for different values in different problems. That's
Okay.
But what's
It's gotta
not
be
okay
untangled the
is for a
measurement.
symbol to
Oh,
stand
yeah.
for different values in the same problem at the same time.
No, I think the answer is 12. Oh, 2 times 6 is 12, but I thought you wanted me to measure the I thought you wanted me... Okay, yeah, 2 times 6 is 12. Yes. But I thought you wanted me to figure out the area of the triangle in a 2 by 6... a 2 by 6 rectangle. I thought that would be 4. Okay, something Mrs. Spicy Gimme says, darn, I wish I was doing this algebra. Okay, yeah, I gotta go back a little bit. Maybe me too, something Mrs. Spicy Gaming. Oh yeah, it's gotta be untangled. Yeah, a bit, it's gotta be untangled to measure it. Yes, but it is definitely hard for me to measure it's hard for me to untie a knot on a rope if I don't have the knot. I don't know. Okay.
For example, in the problem we just solved, the letter x was used to stand for the number 3, right? But x could stand for a different number in a different problem. Like if someone asked us to solve the equation 5 plus x equals 10. In order for the two sides of this equation to be equal, x must have the value 5 in this problem, because 5 plus 5 equals 10. So x, or any other symbol, can stand for different values in different problems. That's okay. But what's not okay is for a symbol to stand for different values in the same problem at the same time. For example, what if you had the equation x plus x equals 10? This equation says that if we add x to x, we'll get 10. And there's a lot of different numbers that we could add together to get 10, like 6 and 4. But if we had the first x stand for 6 and the second x stand for 4, then x would stand for two different values at the same time.
Okay, so I guess, okay. Okay, so... Okay, so x equals 6 or x equals 4 when x is supposed to be on the same number. Okay, I guess.
And things could get really confusing.
Okay, algebra I get is a plus b equals 10. B equals 2. Dash b. B equals 5. If he had, that is, I'm a little confused on that one, something Mr. Spicy Gaming. Okay, oh, I see. b equals 2 or b equals 5. Oh, I see the issue, man. Jeez. Okay, if you had a handful of pennies and laid them in a pattern 2 wide and 6 long, how many pennies would there be laying there? Okay. So A would be 0 and B is 10. So A would be a 0 and B is 10. Okay. I guess that would make sense then. Yeah, you're right. That would make sense then, Sultan Mr. Spicy Gaming. Okay. If I had pennies and laid them in a pattern 2 wide and 6 long, how many pennies would there be lying there? Okay, 2 plus... I can only assume that would be an addition problem. Okay, so 2 plus 6, let's see, 6, that's about 8. I think about 8, Ebib. Okay, and 8 is a multiplication. Oh, jeez. Okay, so A is a multiplication. So 0 times whatever number. So 0 times 0, 0 times 10, or something like that, would still equal 0. I think if I remember correctly, it was like that when I was in school. And so B would definitely equal 10 then. Yeah. Jeez, algebra is hard. A rectangle of 2 pennies would be 6 pennies long. Okay, a rectangle of 2 pennies. Okay, so a rectangle, so there's 2 pennies on one side, 2 pennies on one side, and then 2 pennies on this side, and then 2 pennies on this side. So that would be 6 right there. So I was never taught I never taught things like that in school, Ep. You see what I mean? I was never taught things like that in school. Let's see here. No, a dash is multiplication. Okay, Morrow, after this, watch how to find probability. Okay.
If you wanted symbols to stand for 2 different numbers at the same time, you'd need to use 2 different symbols, like X and Y. So in algebra, whenever you see the same symbol repeated more than once in an equation, it's representing the same unknown value. Like if you see a really complicated algebraic equation like this, where X is repeated a lot of different times, all those X's stand for the same value, and it'll be your job to figure out what that value is. Okay, so for any particular equation, we can't use the same letter to represent.
We're gonna give Mario a headache.
Well, what about the other way around? Could we use 2 different letters to represent the same number? Yes, and here's an example of that. Let's say you have the equation a plus b equals 2. What could a and b stand for so that the equation's true? Well, if a was 0 and b was 2, then the equation would be true. Or we could switch them around. If a was 2 and b was 0, the equation would also be true. But there's another possibility. If a was 1 and b was also 1, that would make the equation true, right? So even though a and b are different symbols and would usually be used to represent different numbers, there are times when they might happen to represent the same number. Oh, and this problem can help us understand something very important about how symbols are used in algebra. Did you notice that there were different possible solutions for this equation? In other words, b could have the value 0, 1, or 2 depending on what the value of a was. If a is 0, then b must be 2. If a is 1, then b must be 1. And if a is 2, then b must be 0. B can't have two different values at the same time, but its value can change over time if the value of a changes.
Okay.
In algebra, B is what's...
Okay, now I think... Yep, that's the stuff we learn. I was taught they would be the same, or they would have the same name. I was never taught like this in my entire life, so I don't know.
It's called a variable because its value can vary or change.
Okay, so I think I get. Okay, we also learn how to find things in multi-step equations. I never learned things like that, man. I never learned things like that. Okay. So, judging by what this person is saying, is that, okay, so I see. B cannot be greater than A. So, if A, let's see. Or, yeah, B is greater than A. Or is it? Okay. Okay, so it looks like A equals 0. So that's 0 plus 2 equals 2. Well, after this, how to find the answer in a multi-step algebra equation. Okay.
In fact, in this equation, both a and b are variables because their values will change depending on the value of each other. Actually, it's really common in algebra to refer to any letter as a variable, since letters can stand for different values in different problems. But at mathematics, we'll usually just use the word variable when we're talking about values that can change or vary in the same problem.
Okay.
Right. So far we've learned that algebra is a lot like arithmetic, but that it includes unknown values and variables that we can solve for in equations. There's one other really important thing that I want to teach you that will help you understand what's going on in a lot of algebra problems, and it has to do with multiplication.
Multiplication!
4 basic arithmetic operations: addition, subtraction, multiplication, and division. Although in algebra, you'll usually see division written in fraction form, like this. In arithmetic, all 4 operations have the same status, but in algebra, multiplication gets some special treatment. In algebra, multiplication is the default operation. That means if no other arithmetic operation is shown between 2 symbols, then you can just assume that they're being multiplied. The multiplication is implied.
Okay, so what this person is saying... Okay, so the person is saying it's like this. Okay, so the person is saying like this. A space B. So, since there is no adding, so there is no division, there is no adding or subtracting. So, multiplication is the default. So that means you're just gonna have to really make a guess that it really is multiplication. Jeez. Okay. I'm sorry for pausing the video. It is just sometimes I want to get a point out, and sometimes I just want to make sure I'm getting the information right.
For example, instead of writing a times b, you can leave out the time symbol and just write ab. Since no operation is shown between these 2 symbols, you know that you're supposed to multiply a and b. Of course, you can't actually multiply a and b until you figure out what numbers they stand for. The advantage of this rule about multiplication is that it makes many algebraic equations less cluttered and easier to write down. For example, instead of this, a times b plus c times d equals 10, you could just write ab plus cd equals 10. You can also use this shorthand when you're multiplying a variable
give me a sec.
equals 10.
Okay, this right here is kind of reminds me of the old days. Yeah, of the old days in video games. Maybe something Mr. Spicy Gaming was not here at the time, but normally in many games back in the day, in order for you to play the games, you would have to type in, okay, well, there is indeed an emulator called DOSBox, and it allows you to play DOS games. And you type in codes, in order for you to play a game. For instance, you type in stuff like this. Yeah. Okay. Okay. There. There we go. It used to be like that. It used to be like this, similar to this, if you want to play a game. Normally there is a way for you to automate that by having your own game directory. But knowing that's what it was like back in the day. Morrow, I'm pretty sure that's also called programming. Yes, it is indeed true, so to Mr. Spicy Gaming, that is indeed programming. And that is why that the DOSBox emulator is indeed a emulator for you to play DOS games. And you have to program the emulator to play the game. Test ACC says Algebra. I'm 6th grade with, is this 9th grade? What? I don't know, Test ACC. All I remembered is that I was looking up algebra, and this video came up as number 2 when it comes to learning about algebra. I'm 7th, and we are learning 8th grade stuff since I'm advanced. Oh.
You can also use this shorthand when you're multiplying a variable and a known number, like 2x, which means the same thing as 2 times x, or 3y, which means the same thing as 3 times y. Since the symbol and the number are right next to each other, the multiplication is implied. You don't have to write it down. Finally, some good news. Now I never have to write down that pesky multiplication symbol again. Oh yeah. Not so fast. There are some cases in algebra where you still need to use a multiplication symbol. For example, what if you want to show 2 times 5? If you just get rid of the times symbol and put the 2 right next to the 5, it's going to look like the 2-digit number 25, which is not the same as 2 times 5. So, whenever you need to show multiplication between 2 known numbers, you still have to use the time symbol. unless you use
Confused
parentheses
screaming.
instead.
Me too, ACC.
But aren't parentheses used to show grouping in math? How can you use that to show multiplication?
Okay, so algebra is 2x times 3y. Oh no. I think you were not here during the beginning part of the video. In the beginning part of the video, they showed, addition, yeah, adding and subtracting. I think, yeah, they showed adding in, yeah, see? 1 plus 2 equals x, so forth like that. So they showed only that kind of thing. We learned a little bit of algebra, but like 0.1%. Jeez! 0.1%. I didn't learn algebra at all in my life. In my entire life, I never learned algebra. Algebra 3 calculus. Okay, we'll take a look at the calculus. I really want to see what calculus is about. Okay, test ACC. Yeah, you will learn more next year, I am sure. But if you're in advanced, get effing ready. Get effing ready before you get your brain fried. I'm kidding. But seriously, better get ready.
That's a good question. Parentheses are used to group things, but whenever you put two groups right next to each other with no operation between them, guess what operation's implied? Yep, multiplication. For example, if you see this, it means that the group A plus B is being multiplied by the group X plus Y. We could put a time symbol between the groups, but we don't have to because it's the default operation in algebra. The multiplication is just implied. So, going back to our problem, the multiplication is...
Okay, well, I'm going to a STEM academy. Okay, let me see. I want to see what a STEM academy is. Okay, what is a STEM academy? A STEM academy or STEM academy, a school for science, technology, and engineering and mathematics. May refer to Downingston STEM Academy, a magnet high school in Downingtown, Pennsylvania. Low down on STEM schools parenting. What is the STEM Academy of the USA? See how to convert Fahrenheit to Celsius. No, it's in Mansfield. Okay, it's in Mansfield, I think. Alright, let's take a look. Copy that and this. Let me see. How many STEM academies does Mansfield ISD have? Mansfield ISD has 5 STEM academies. These academies are centrally focused on immersing students in hands-on learning, emphasized with science, technology, and engineering and mathematics in mind. Oh, bro, there's a effing full college course on YouTube. I think that's personal info. No, it is not no, it's not, Substance Mr. Spacey Gaming. All he showed me was Mansfield. And I do believe there's a high population in Mansfield, so... yeah. Alright, Alright, now let's get back to algebra. Okay. So, okay, scroll down. It says school district. Oh, it does? Scroll down. It says school district. MSID to launch a new high school STEM academy. Power of choice. Mansfield Independent School District. STEM Academy at Martin High School accepting applications. Okay. Yeah, so Test ACC is going to a STEM Academy, which is also known as a technical school. Yeah. Yeah, I remembered during a time I was in Maryland, and there was a place called Hartford Tech. It was a Hartford. It means Hartford Technical High School, where the school focuses on science and technology. And that place was pretty darn cool. That place had masonry. Like that technical school I went to as a visitation thing, it had freaking masonry. I've always wanted to learn how to lay bricks at a young age. Like there's a lot of history when it comes to bricklaying. Bro, I swear, they didn't allow me to go to STEM even though I was qualified. Still salty about it. Yeah, it sucks. Okay, now then back to algebra. So it seems here is that a plus b and x plus y, there's a little space here. So it is implied that it's automatically going to be a multiplication. So, if you were to find what's a plus b, then you have to go times that for x plus y, and that would equal that. Okay. Geez, so basically what this is a plus b. So you find the answer to a plus b, and then you put the answer here. X plus y, then you put the answer here. So then the answer here and answer here, answer here. So that's the answer times this answer equals that. Brick masons make a lot of money. That's indeed true, Epip. That is indeed true.
Is just implied. So, going back to our problem, 2 times 5. If you wanted to, you could just put each of the numbers inside parentheses like this. And then you could get rid of the multiplication sign. Now this can't be confused with the number 25. And since the groups are right next to each other, you know that you need to multiply them. Of course, it might seem strange to have just one thing inside group symbols like this, but it's okay to do that in math. An alternate way that you could do the same thing would be to put just one of the numbers in parentheses, like this. Again, you won't confuse this with a 2-digit number, and you know that multiplication is implied. Okay, so we've learned that algebra is a lot like arithmetic, but it involves unknown values or variables that we need to solve for. And we learned that in algebra, the multiplication sign is usually not shown because it's the default operation. You can just assume that 2 things right next to each other are being multiplied. But why do we even care about algebra? Is it good for anything in the real world? Or is it just a bunch of tricky problems that keep students busy in school? Actually, algebra is very useful for describing or modeling things in the real world. It's a little hard to see that when you're just looking at all these numbers and symbols on the page of a math book. But it's a lot easier to see when you start taking algebraic equations and graphing their solutions.
Okay, Epip says, I would like to build fancy barbecue grills for rich folks. And yes, and you better hope that rich folks would invite you to their barbecue.
Graphing an equation is like using its different solutions to draw simple lines and curves that can be used to describe and predict things in real life. For example, there's a whole class of equations in algebra called linear equations. Because they form straight lines when you graph them.
That's familiar.
Those equations could help you describe the slope of a roof. or tell you how long it will take to get somewhere. Another class of algebraic equations.
Okay, so what this person is saying that people use algebra when it comes to making houses. Like how the shape of the roof is gonna be, how long the house needs to be, that kind of a thing. Okay. So people use algebra for construction. I can only assume they use algebra for architecture.
Called quadratic equations can be used to design telescope lenses.
Yeah, use
or
the pool.
describe
Yeah.
how a ball flies through the air, or predict the growth of a population. So algebra is used all the time in fields like science, engineering, economics, and computer programming. And even though you might not need algebra to get by in your...
Oh, that reminds me. This one over here. I think I remember many years ago. I trolled one of my friends by using binary. I was like saying, hey, what's up? 0 0 1 0 0 1 0 1 0 0 0 0 0 0 1 1 1. And then my friend was like, hey, I'm fine. And then I was like, 0 1 0 0 1, man. 0 0 1 1 1 0. Oh man, it was such an awesome troll. I should possibly do that to people that I do on live streams with, but I'm gonna have to do it like in a Discord call or something. It's gonna be so hilarious. Maybe I'll go over to Rust and I'll troll some people with binary.
your day-to-day life.
So divide both sides by 3. That means x equals 42. So in 3, 2, 1. Yes! Now see how much butter I need.
It's still a very useful part of math. Thanks for watching Math Antics, and I'll see you next time.
Okay, that was cool. Copy that and I'll paste you here. Okay. Okay. And so now, let's see. Okay, let's see. What kind of things or something Mr. Spicy gave me wanted to look up? Here we go. Morrow, after this, watch how to find the answer in a multi-step algebra equation. Okay, multi-step equations. Okay.
Hello, welcome to the video on solving multi-step equations. This will be a lesson on this topic, and let's take a look at our objectives here. So the first thing I'm going to do is go ahead and define multi-step equations, and then we're actually going to learn the process to solve multi-step equations. Okay, so multi-step equations, what are they? Well, it's basically what the name is implying, or equations that are going to require multiple steps. So here's an example of one right here to the far right. Now, to actually solve a multi-step equation, it's actually kind of a series of 1- and 2-step equations. So,
Okay.
to solving these things is already to have mastered 1- and 2-step equations. Okay, and at this point, you should have already done that. So let's take a look at these two problems here. The first is a 1-step, and then the second equation is a 2-step. So this is a good chance for you to review and just to kind of check your understanding whether you've already, kind of mastered these basic equations. I want to pause the video and give these problems a try. Okay, so x plus 2 equals 9. So we're going to go ahead and subtract 2 from both sides of the equation. We get x equals 7. That was our one step to solve this equation. Okay, pretty easy, pretty basic.
Okay.
So hopefully most of you got this and totally understand why the solution is 7 and understand inverse operations. Now the
Okay. Alright, I think I get it. Okay, 9 minus 2 is 7. So, the 2 is x. So I can only assume that 2 is x. Okay, is it really that? No. Okay, so I guess x equals 7, so, okay. So 9 minus 2 is indeed 7, so... 7 plus 2 is 9. Okay, so it is 2. No, I mean 7, okay, yeah, x is 7. Because it's, okay. Okay, I'm getting somewhere.
it's a two-step
Okay.
equation. The first thing I'm going to do is add 5 to both sides. Okay, then I'm going to go ahead and add down. I'm going to get 3x equals 15. And then my second step is I'm going to divide both sides of the equation by 3. And then I'm going to get x equals 5. Okay, so
Okay. This part confuses me. Okay.
down, I'm going to get
Okay.
3x equals 15.
Okay, so 3x, which is 5, 10, 15. Okay, and 5... Yeah, 15 minus 5 is 10. Okay. Okay, I get it now.
And then my second step is I'm going to divide both sides of the equation by 3.
Okay, so because of that, yeah, because of the 3, so you had to use the 3 somehow. So he divided that by 3. Okay.
And then I'm going to get x equals 5.
Because 5, 10, 15. Okay. Okay, I think I get it. Okay.
Okay, so if you got both of these equations correct and you
Yeah, I think I did, yeah. Yeah, 5 minus, 15 minus, 3x, which is 3, okay. Okay, I get it. Okay, I get it. Okay, so 3x stands for 3 times 15. Okay, Morrow, I'ma go take a nap. Probably won't be back. See ya. Okay, Something Mr. Spicy Gaming, I'm hoping that you have a good nap. Okay, I get it now. Okay, so 3x stands for 5 times 15. I mean, 3 times 5 is 15. Yeah, okay. Yeah, so 3 times 5 is 15. So then you minus 5, that makes 10. Okay. So then 10 plus 5 is 15. 3 times 5 is 15. Yeah, 3 times 5 is 15. So the x is 5. So the x is definitely... Okay, alright, I think I get it.
understand them and there's no problems, then you're really you're ready to take on multiple step equations, because multi-step equations are essentially just a series of 1 and 2 step equations all kind of wrapped up into one equation. Now, the two things you're going to need to solve a multi-step equation are, one, you're already going to have to know how to solve these 1 and 2 step equations as we already talked about. And the second thing is you need a kind of a general set of directions, a general process. And that's what this is here. Okay, so you might want to go and write this down and put this in your notes. And then we'll actually take a look at a couple examples and see how to apply this procedure. Okay, so the first thing you're going to do is you're going to apply the distributive property when you see two parentheses and a number outside of it. And I'll show you here an
Okay, I can only suspect that's multiplication.
example what I'm talking about. Then next, you're going to combine like terms on each side of the equation. Okay, then you're going to move on and you're going to put all the variable terms on the left-hand side of the equation and all the numbers on the right-hand side using addition and subtraction inverse operations. Remember, what we're trying to do when you solve when you're solving an equation is to get all those variables on the left and all the numbers on the right. Okay, so that's what we're talking about in step 3. Then lastly, after step 3, what you're going to be left with is a basic one-step equation. So you're just going to solve that basic equation and you'll get your solution to your multi-step equation. So let's take
Okay, yep, it's definitely making algebra less word jumble.
Okay, so first thing is we're going to go ahead and apply the distributive property when we see parentheses. And we see parentheses with a number outside of it. So in other words, this is a distributive property situation. Okay, so you have 3 parentheses y plus 2. Now let me emphasize the distributive property because oftentimes when students struggle with these multi-step equations, it's because they don't really understand the distributive property. So go back and review the distributive property if you need to do that. Okay, if you're when you're doing these problems and you're seeing that you're getting them wrong because of the distributive property, obviously that's an area you want to go back and review. Okay, so the first thing I'm going to do is apply the distributive property. So I got 3 times y plus 2 plus y equals negative 14. So that's going to be 3 times y. This is the distributive property.
3y.
3 times 2, which is 6.
Procrastination is my middle name.
Okay.
So solving a 3,000-piece puzzle sounded better than studying for math. Go and
Plus,
Okay, seriously, YouTube, stop it with the personalized ads. It's like I was looking at math things and then they put up a thing. They put up an ad about math. In a way, math, yes, but it's for puzzles. And the person actually said math in it.
y equals negative 14. Okay, so notice how I rewrote the equation right underneath it, but this time I used the distributive property to rewrite it. Okay, so that's step 1. Okay, step 2 is to look for opportunities to combine any like terms, okay, on either side.
Okay, so 3 times, so it's 3 times 2 is 6. Or, yeah. Yeah, either way, it's going to be 6. Yeah, 3 and 3 is 6, or 3 times 2 is 6. Okay, so that's... Okay, so it's y.
The equation. So we want to look at the left-hand side independent of the right-hand side and just look for like terms. Okay, so do we see any like terms here? Well, 3y and y are like terms, so we want to combine them.
Oh.
Okay? So 3y plus y will give us 4y plus 6 equals negative 14. Okay, so if you notice here, what I'm doing is I'm rewriting the equation over and over again, but each time I rewrite it, I'm making it simpler. Okay, that's the whole idea behind solving these multiple.
Okay, how in the world did he get y?
All your work.
Okay.
Okay, so what I did there was I combined like terms, okay, on either side of the equation. In this case, it was only like terms on the left-hand side. So next, okay, I'm going to move all my variable terms to the left-hand side.
Okay, seriously. How does people do this? How Okay, how do you all do this? Okay, how do you all... I'm serious, I'm sorry for repeating myself, but how do you all do this? Okay, I just want to check out something real quick. Okay, 3 likes on the stream. Okay. So far for an experimental stream, it's going quite well. Okay, so 3 times 2 is 6. You don't. Me either, Abib. This is insane. And young kids gotta learn this stuff?
So if I look here, my variable term is already on the left-hand side. There are no more variable terms. But I also have to move all my numbers to the right-hand side. I'm going to use addition and subtraction inverse operations to do that. So here I have a 6. I don't want that 6 there. I need to get that 6 over to the right-hand side with that negative 14. So I'm going to subtract 6 from both sides of the equation. Now at this point, this is a simple 2-step equation. Okay, so hopefully you've noticed that 4y plus 6 equals negative 14. Really, at this point forward, you can go ahead and just take the steps to solve a 2-step equation and get your solution. But we're just going to go ahead and follow this general procedure that I gave you. So subtracting 6 from both sides, I get 4y equals negative 20. Okay, and then I'm left with this basic equation. So I'm going to go ahead and solve that. 4y equals negative 20 is a basic equation. So I'm simply going to go ahead and divide both sides of the equation by 4.
Okay, so 4y is negative 20. How in the world did he get negative 20?
4, and I get y equals negative 5. Okay, so that's it. This is how you
So
solve
y equals negative 5?
Use these steps as a general guideline and just kind of walk it through, but notice the way I'm working. Okay, nice and neat. I'm showing all my work, and I'm essentially rewriting the equation simpler every time until I get to the most simplest form of that equation, which is the solution. Y equals negative 5 is the simplest form of this equation right up here. Okay? All right, so let's go ahead and try another problem.
Okay.
So here is our procedure again. So the first thing is I'm going to apply the distributive property when we see parentheses. So in this case,
There is none?
any parentheses, any situation where we have to apply the distributive property? No. Okay, so you're not always going to have to do these steps.
Okay,
do them if you
2x is 12.
step equation. So that's done. So now the second thing is
2
I'm gonna
times
combine my
10.
terms on each side of the equation.
No,
So
2
if I look on the
plus.
left-hand side,
Okay.
2x minus 10. There's nothing to do there. On the right-hand side, I have 12 plus 4x minus x. So these two are like terms. So let's go ahead and combine those. So I'm going to rewrite.
Now it's getting confusing. Yes, it is.
Minus 10 equals 12 plus. Now you got to know how to combine like terms. Another area, if you're weekend, you want to review. So 4x minus 1x is going to be 3x. Okay.
Okay.
The next step is.
Okay, so I guess I can understand that. 4x minus 1x is 3x. Okay. So then he's... Okay, so then he simplified the problem again. Okay, so he still needs to figure out about the x. But he still managed to get the, Okay. Yeah, so it is... Okay. So since... Last time I remembered is that since the 12 does not have an x, it cannot be added or subtracted. So it would still be 12 plus 13x? I'm not sure.
We're going to move all the variable terms to the left-hand side. Okay, so therefore this 3x, I'm going to move over to the left-hand side. And then I'm going to have to move all my numbers to the right-hand side. So this negative 10, I'm going to have to move to the right-hand side. So let's go ahead and handle the 3x.
Okay,
first.
so...
To the left-hand side. So I'm going to subtract 3x on the right-hand side here. Okay, but I also have to subtract 3x on the left-hand side. And notice how I'm...
Okay, so he's putting the minus 10 here.
So rewriting this equation, I'm going to get negative 1x minus minus 10 equals 12. Okay? But now I still have to take care of my number. I have to move it all to the right-hand side. So I'm going to add 10 to both sides of the equation. Okay, these are just inverse operations. We talked about this way back in one-step equations, how to move numbers or variable terms to the left or right-hand side. Okay?
Okay.
All right, so
Okay, I think I get it now. Okay, so... Okay. So... Okay, so... Okay. Alright, 2 minus 3 is -1. Yeah, so that's -1. Okay, so then I guess we put... Okay, this is confusing.
I'm going to go ahead and add 10 to both sides of the equation. I'm going to get negative 1x equals 22. All right, so
Okay.
stuck with the
Yeah, that makes sense. 2 plus... Yeah. 2 plus 0 is 2. 1 plus 1 is 2, so that's 22. So I guess in calculators they don't put zeros. So I guess that'll be 1x, I guess.
basic one-step equation. So to solve for x, all I got to do is divide negative 1 by both sides of the equation. I get x is equal to negative 22. And that's it. Okay, so once again...
What?
Oh, man.
Still searching YouTube for math help? Are the videos from...
Yep, see what I mean, everybody? There, it's like I look up math. When I do live streams or something like that. On today's live stream, it ends up being ads about math.
2006 really helping? Aren't you tired of finding videos that aren't getting you...
You know, you use this procedure as a general guideline. Not every single step is going to apply, and every step is going to be a little bit different than maybe your previous problem that you did. But if you use this in kind of like step-by-step order, you should have no problem solving these multiple step equations. Of course, you want to practice this. Then after a while, it's just going to be kind of become second nature.
Okay, so I guess it would make sense. With practice...
So in review, the key to solving these multiple step equations is to master the one it's two-step equations. Okay, you have to have that down before you tackle multi-step equations. You also really have to be an expert at the distributive property, and you have to know how to combine like terms. But if you know how to do all three of these things, then you'll know how to handle these multiple step equation problems. Okay, so you definitely want to practice this. Keep working hard. We'll see you soon.
Okay. I can copy that and put you over here. Okay. A 10-minute video is better than several hours in class that isn't something. Who else watched this video before their math test? I wish you was my teacher in school. Oh, gee, thank you so much. I thought it was stupid because it was too confusing when our instructor shows us. I was about to drop my math class lesson. This is a rare time where a teacher explained it without saying anything. Yeah, let the people figure it out. Thanks, man. I understand it more, and thanks for walking me through instead of saying try it. It's like similar to having a sandwich. Here, have this sandwich. It's good. You gotta try it. These comments. Yeah, they're awesome comments. when you get 25% on a math quiz and there's a test tomorrow and you're in advanced math with a C. So I missed one class and I did not want to hold the class back. So this guy, he'll help me a lot. Save me from getting behind in online school. Thank you so much, you rock. I wish you were my math teacher. You're so much simpler. You can explain things in 10 minutes while teachers be taking 2 class periods to explain one-step equations. Thanks from a mom helping her teen. Man, these are awesome comments. Okay, let me copy the video. Copy the link to the video. Oh. Okay, there we go. I forgot there's an autoplay on YouTube. Okay, gotta go back.
Hello.
Okay, we gotta get the person's name in. There we go. Copy that. There we go. Okay. Okay. Let's see. I think there was another one that something Mrs. Spicy Gimme wanted me to look at. Let's see. Yeah, okay, I do not recall Mr. Something Mrs. Spicy Gimme wanted me to look at another form of math. So let me take a look at calculus. Oh, jeez. Understanding calculus in 10 minutes. Oh, man. This is really gonna fry my brain. But I guess I'll make some good content.
I need to find the best way to learn math and science.
It's brilliant.
Whoa.
Here's a new way to learn math.
Okay, understanding calculus in 10 minutes. Okay, so that's the topic of this video. Now, notice the video isn't saying, or my topic isn't, or title is learn calculus in 10 minutes, or master calculus, or totally, understand it completely. Just basically understanding calculus 10 minutes, like understanding what it is. That's what the whole point of this, and really.
Yeah, I didn't say mastering.
My kind of main goal here is to kind of maybe demystify what calculus is and lessen the intimidation factor, because there's a lot of students out there that say, oh, I could never do calculus, it's too complicated, etc. And there is a lot to learn in this topic, but hopefully you'll kind of see the big picture here. But let me just, before we get into it real fast, let's just talk about where you would take calculus as a math student. So generally in high school, okay. So in high school, for most students, you start off with Algebra 1, then you go to Geometry, you go to Algebra 2, and then...
Okay, first of all, as I did say before, when I was in high school, or perhaps in my entire life, I have never been to Algebra 1, I did not do Geography, I did not do Algebra 2, I didn't do anything of the sort.
You go to Pre-Calculus.
And then I did not do Pre-Calculus.
In your last year of high school. Now, some students accelerate this and they'll actually end up in calculus in their last year. Now, when you go to college, I would say maybe about 70% of the majors, degrees in college, right, so at the university level,
Many of them, I mean, well, definitely over half, are going to require you to at least have one semester of calculus. So if you don't take it in high school, you'll see a little bit of it in college. Now, if you're some sort of science or technical major or finance or whatnot, you'll probably take even more of it. So it's probably going to be in a lot of your futures if you're going the college route. Okay, so that's just basically where it lies in the spectrum of learning. All right, calculus in 10 minutes. Let's get right to it. So calculus basically helps us figure out kind of two problems, two kind of things in math. I'm going to start with one that's kind of easy. And that would be like the area and volume problem. Okay.
He has
so
more better handwriting than I
let's
do.
sketch out here real quick. So this is like a rectangle, right? So if I said find the area of this rectangle, we have a formula for this, if you recall. So it would be like length times width, right? So the area of this rectangle is going to be the length times the width. No problem, okay? So
Okay, A stands for area, so it's okay.
Do a circle.
Okay, so the area, so the A stands for area, that's why it's capital, so A equals length times width. Okay.
Right. What if we had a circle? And this is not a perfect circle, obviously, but if I said find the area of this circle, hopefully some of you out there, or maybe most of you, remember there's a particular formula for this, okay? It's pi r squared, r being the radius.
Pi?
From the
Don't
center
get me
of
started on the area of pi.
And pi is a number of 3.14 approximately. So I can use this formula to figure out the area of this circle. And for this rectangle, I can use this formula. Now, let's just do one more example. What if I had a triangle, okay? So, again, if I want to know the area, this would be...
Okay, something Mr. Spicy Gaming did this to me in the earlier part of the stream. He asked me, let's see, I think he was also in the Discord. Let's see, did he tell me down in the Discord? Okay, no, I don't think so, but I remember that something Mr. Spicy Gaming kept telling me, what is the area of this triangle?
1/2 base times height, right? So this would be the base of the triangle. This would...
Okay, so basically what he is saying, I should have... Okay, so... You put the triangle in half. So... You put the triangle in half and then times it by the base value. Okay.
The height. Okay. So formulas help us find the area. And by the way, this goes for volume as well. So these formulas come in handy with these kind of basic figures like triangles and circles and etc. So let's take a look at where calculus helps us out. Okay. Where it's a tremendous value. And by the way, I can't overstate the importance of calculus in mathematics, engineering, science. I mean, it's huge. Really is as powerful as you may think it is. Probably more so. All right. So what if we had some crazy figure like this, for example? And I'm just trying to draw something. Okay. So what if I said find the area of this particular object or this figure? Well, probably you're going to be looking for a formula, right? You're going to be, okay, yeah, I could find the area of this. Just give me the formula. Well, guess what? There is no formula for something like this. This is very challenging, okay? So calculus helps us figure out the area of crazy-looking figures like this, okay? And volume. They don't have to be as, abstract as this, but this is what calculus can do for us. This is the power of it, because without calculus, we would have to go through and just kind of like maybe try to estimate the area of this particular thing, but calculus can give us the exact area. Okay. Now, let's suppose that I took this this figure And let's kind of put this like on an axis, okay? And I circled it around, spun it around. So maybe it's kind of doing this business. Now, I don't know what it would exactly look like, but it might look like an object, maybe something like this.
Okay.
Procrastination is my middle name. So solving a 3,000 piece puzzle sounded better than studying for physics.
Kind of maybe sketching this out. All right, and then it looked like it would have some sort of hole in the middle, right? Maybe like this.
Okay, what the world?
Very difficult to kind of maybe imagine, but you can see if you did have this.
That looks like a cool piece of furniture.
Right, and then you just kind of rotated this around, you would create some sort of weird looking figure like this. So this figure, you would be looking for the volume, right? Like how much water would be able to fill this particular, let's say maybe it's a vase or something. You could put in, okay? Once again, calculus will tell us exactly how to do this. And you may think, wow, you must have to go through all kinds of crazy advanced calculations in order to do that. And surprisingly, it's really not as bad as you think, okay? Once you
Okay. Okay, I'm gonna have to stop the video because I think I might be getting a headache. Okay, I'm just temporarily stopping. Jeez, I was never taught things like this when I was in school. Ugh. I wonder. We'll come back. We'll come back to the video. It's just for right now. Okay, just for right now, we need to go. Let's see. Yep, my math teacher. After I explained it to him how I used a different method to get the same answer, amazing, every word he just said was wrong. Newton gets acclaim for inventing calculus. Leibniz, we stand amidst my achievement. Okay. Oh, that is awesome. I love that meme. It gets a way for people to learn something if they were to solve an equation. Like, students may want to look up something over the internet, but knowing that somehow the school does not want people to use their phones while they're in school. So it looks like that the math teacher come up with some kind of genius idea saying if you solve this equation, you'll be able to figure out the 10-digit password for the answer for the Wi-Fi. Oh, that is brilliant. That is very brilliant. I like that. Man. Yeah, there's a meme for everything. Yes, there is. All you gotta do is to put something that you're interested in and put memes, and odds are there's memes about it. Okay, math break. 1, 3, 5, 7. What number will be next? 2, 1, 7, 3, 4, 1. Because if x then f equals 1, 3, 8. Okay, F is 1. F, okay. Okay, I think the parentheses equals multiplication, so F times 1 is 1. F times 2 is 3. Jeez, I don't get it. Okay. Dad, why is your eyes red, son? Son, I smoke weed. Dad, don't lie. You're crying because you weren't able to solve the integral. I mean, these memes are awesome. That looks like Chris Pratt. This person here really does look like Chris Pratt. And it says, I don't understand calculus, and at this point I have to find a surrogate. Okay. You should have studied for calculus instead of making memes. Oh man, these memes are awesome. Okay, why is everyone else crying? Okay, why is everyone else crying? It's just an AP calculus exam. Ah. Oh man. Gotta love these calculus memes. I have a calculus worksheet. Pre-calculus is just algebra crack. Ah, that's Tuvok. Tuvok from Star Trek. Calculus be like, take the derivative of the derivative to identify the inflection. X med scholarship x.me.net/500. Tuvok still has it. Okay. Okay, let's see. How long have I been streaming for? Okay, I have been streaming for about an hour and a half now. Okay, I do believe that this is gonna be a good time for me to stop the stream from here. And man, for an experimental live stream. Yeah, for an experimental live stream, it was definitely quite a bit of fun. Like, we learned something, like, I learned some things, but I'm not sure about you all out there. If you all want me to continue doing this, experimental stream, please let me know in the comment section on the next subject that you want me to do this kind of stream on. Yeah, in the comment section. But I'm hoping that you all have enjoyed yourselves. Have a good day.